everybody and welcome to 4-Minute Physics. So during this video I'm going to take you through the atomic structure section of what you need to know for your GCSE science, your GCSE physics. I'm going to do this in hopefully under 4 minutes, so that's the challenge. So we're going to start the timer and see how we get on. Alright, first thing to know is what are atoms actually made of? Well, atoms are made up of 3 subatomic particles, and those subatomic particles are called the proton. The proton is positively charged, it has a charge of +1, and it has a relative mass of 1. The neutron is a 0 charged particle, but it also has a relative mass of +1, so it's a very similar size to the proton. And finally, the electron. Now, the electron is absolutely tiny. It has a negative charge of -1, but because it is so small and compared to the protons and neutrons, it has a relative mass of 0. And just to kind of put a little bit of comparison in, what I've got here is a sphere which represents the proton, and the electron in comparison would be about that size there. So that's really quite small in comparison to the proton and the neutron. Okay. In terms of what we look at when we're seeing or representing atoms, and if we're asked to draw an atom as well, this is the kind of thing you might see. It's very important that whenever you draw an atom, you're very clearly labelling the different elements to it. So here we've got the protons that I've done in red or pinky colour, the neutrons here are in green, and the electrons are represented by little X's in the shells surrounding the nucleus. Now, when we need to draw atoms, we do have to follow a few rules, and these are worth remembering. So the first rule is that atoms always have the same number of protons as they do electrons. So in this example here, there are 3 protons in the nucleus. There are 3 electrons orbiting that nucleus as well. The second rule is that only protons and neutrons are obviously found in the nucleus itself. Okay, so that's really important to remember that. And the final rule is to do with the electrons and the shells that they occupy. And I'm going to just go through those rules just separately here. So in this particular example, I've drawn an atom with a few more electrons in it. The rules are that only 2 electrons can ever be placed in the innermost shell. When you have filled that shell, you must then draw another shell outside that one. So this will be our first innermost shell, this would be our second shell, and in the second shell you can fill up to 8 electrons in that shell. If you then fill this shell, you then move to another shell, and that one also can hold up to 8 electrons. In this case, I've got an atom here which has 6 protons in it, so I've got 2 electrons in the innermost shell, and I've got 6 electrons altogether by putting the 4 in the outermost shell in this case. In terms of atomic notation, we need to know how we write atoms and how we can represent them using symbols rather than just drawings. I've got 2 different atoms here on the screen, and I'm going to represent these by the atomic notation. So the first one here, this is lithium. Lithium is a symbol Li found on the periodic table, so make sure you know where you can find these symbols. And the top number here, 7, represents the total number of protons and neutrons found in the nucleus. The bottom number, in this case 3, is the proton number, or the atomic number. It's how many protons there are in the nucleus. In this case, I've got carbon. Carbon has 12 particles in the centre of the nucleus. These are 12 protons and neutrons. I could count those up there. And 6 are how many protons there are. In this case, we can now work out what we've got in terms of neutrons. If there are 3 protons, there must be 4 neutrons to make up to 7. If there are 6 protons, there must be 6 neutrons to make it up to 12. These have terms that we must remember. The top number is called the mass number, and the bottom number is called the atomic number, or the proton number. Okay, so we managed that in just under 4 minutes. It's pretty good going. I hope that was useful, and I hope that you've managed to pick up something that perhaps you didn't know before, or it's helped kind of remind you of the key things that you need to know. In the next video, I'm going to talk a little bit about isotopes and how they work, and all about the atom history and how we understand what atoms look like today. Okay, thanks for joining me on 4-Minute Physics. See you next time.